It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my co-host, Andy Grabner, who's making fun of my mustache. Andy, I got to tell you, I had another dream.
Another nightmare, or was it a pleasure dream?
It was more of an interesting dream. So yeah, it was not a nightmare. I wouldn't call it a pleasure dream because you were in it, and that's closer to nightmare, I'd say. But there was nothing actually terrible. So I was outside and I was looking through my telescope. See where that's going. I was looking through my telescope at the moon, and suddenly I see a little Andy Grabner running around the moon without a helmet even. And I'm like, Andy, I yelled up to the moon, Andy, what are you doing on the moon? And you yelled back, and somehow I could hear you. And you were like, oh, Brian, I am up here on the moon. I'm like, yeah, I could see that, Andy. How did you get there? What's going on? He's like, well, everybody's going to the moon now. Everyone's making their own rocket ships, so I made my own rocket ship, and I went to the moon. And I was like, yeah, but what are you doing on the moon? And are those my kids with you? Why? So you still had my kids from 2 dreams ago, and I was just really confused as how you could even breathe without the helmet. But really, what dawned on me is I was observing you through this telescope on the moon, could somehow communicate with you, get information back from you, and was just astounded that you did this yourself and you made your own rocket ship and you got there. And then I woke up and I was just confused about why I keep having weird dreams about you, Andy. Yeah.
Did I leave a trace on the surface of the moon?
No, you magically left no footprints.
No.
It was, because I don't know. You're just a magical being, Andy.
But for some reason, I think you made this up. I don't know why.
Well, I see where you were going. There. Yeah. I messed up your trace bit. Sorry about that.
That's okay.
You're too smart for me.
But that's a good one. And I hopefully, if Roman is listening, because I talked with him the other day.
He messaged me, which inspired me to...
come up with a dream. Okay, so this is your dream story again. But now, enough with the dreams, back to reality. Back to observability, back to tracing.
Back to observability, we didn't even go there yet.
Yeah, well, you observed me on the moon. We have an awesome guest today. He's not only, I think he's not only an expert in the field that we're talking about today, he's also a book author. Oh. And just recently published the Practical Open Telemetry book, which everybody should definitely take a look at if you're interested in open telemetry. But now I think it's really time that I hand the mic over to Daniel Gomez Blanco. Welcome to the show, Daniel. Thank you so much for being here. And do us the favor, please introduce yourself to the audience.
Hello. Thanks for inviting me to your show. My name is Daniel. I'm a principal engineer at Skyscanner, and I'm the tech lead for observability and our observability strategy long term. And I've been just leading a really exciting project that has got to do with us adopting open standards and trying to rethink how we do observability at Skyscanner.
Uh-huh. And what do you think about the strange dream story? Was it?
I can see where that was going. I was getting the tracing part of it. Yeah.
I missed the tracing part. I was still wrapped up.
Yeah. Hey, Daniel, I think as I said, we will also leave all the links. So, folks, if you are, interested in open telemetry, it's been a topic we've been discussing for quite a while now, off and on with different experts in the field. But I think we can never stop educating people about it because it still needs a lot of education. Like Brian and I, we've been talking about performance engineering and performance patterns for so many years, and still we look at applications and are still wondering, does anybody listen to us because they still make the same mistakes? So for me, one of the ways I actually got in touch with you is because I found some of your presentations that you recently did at QCon, as a recon, and for me, it seems, right, we've been in observability for I had my 15 years anniversary, so we've been doing this for a while. Brian, you've been around also for very long, right, in our industry. And for us, distributed tracing in the company we work for, right, it's nothing earth-shattering new. We've been doing this for a while. But my question to you, Daniel, is why all of a sudden do you think we see such a huge uptick? Observability, everybody talking about distributed traces. Why the sudden new hype about this whole thing?
So I think if we go back, I guess 10 years, like, you know, I think it's something that perhaps should have happened before when we started to adopt, like, you know, cloud native deployments, microservice architectures. There are way more components that are, you know, moving pieces in these architectures, right? And I think over the last 10 years, we've been adding more and more data to our systems in a way that sometimes, you know, if we don't think about tracing, we think about metrics and logs, for example, right? If you take a monolith that you had, you know, 20 years ago, you try to break that down into microservices, but you're still using metrics and logs, then you start to see that, you know, the data that you produce starts to, you know, skyrocket. And then your engineers can no longer make any sense of it, really. So I think there was like a case where like companies that got themselves into that position see that, you know, the amount of data they've got is too much. It's not useful, it's not actionable data most of the time. And then and I think it's been more like you know, the moment that organizations start to look at that and, you know, the value that they can get from data, that's when they think, okay, so we need something better, something that can describe systems better and allow us to debug regressions faster. So I think it's just basically we're getting more deployments, we're getting faster in the way that we deploy. Like we're deploying thousands of times a day, where like before, you know, maybe some other companies in the past used to deploy, I don't know, once every 2 months, right? Now we do it like, you know, dozens or hundreds of times a day. And then with more moving pieces, you need something better, right? You need observability.
Yeah. So basically things got out of hand almost. And then we needed to find a way to better control, better specify and standardize the way we do it. I mean, I actually thought you went into a different direction when you started talking about in the old days, right? Where I think we had obviously simpler systems. And I remember, Brian, when we started observability and kind of distributed tracing back in the days when the world was dominated by Java, right? I mean, it was
.NET, but Java was dominated by Java.
But
we
in the
hated
beginning
working with .NET at that time.
Yeah, but in the beginning, everybody in our industry started building agents for Java, and with that you covered a huge ground, right? And then maybe added .NET, and then Daniel, what you said, I thought was really interesting because now with kind of containerized systems and you having Kubernetes and everybody can basically pick from not hundreds but many different runtimes that fit their needs. It's impossible to write, I guess, agents for all these technologies, and therefore I really like that we have come to a situation where we say, okay, we need to standardize first of all what we collect, how we collect it, but also I think need to give the power back to the people that actually build these systems and build these frameworks and applications and put their instrumentation in, instead of relying on some vendors to figure out a way how to reverse engineer runtimes.
Vendors, or even like, the engineers themselves, like, you've got, if you, let's say if you're only relying on open source software, it may be up to the engineer that is using a particular library to add the telemetry to it, because that library doesn't produce any metrics, right? And it makes sense, because if you're the author of a library, what do you use? Do you use Prometheus? Do you use StatsD? Do you use it's very difficult for a library like author to decide on what SDK, what metrics client to use, for example. But when you think about OpenTelemetry, you've got libraries that can describe themselves, and then have the user of the library decide how they want to export that data, right? Which is what is this all about? Is when you've got all those different moving parts, and you've got systems and libraries that describe themselves in the way that the author intended, there's no need for, someone else to come after and try to sort of add telemetry on top. So that's an interesting feature, or an interesting feature of OpenTelemetry.
What I would be interested in, and we talked about this a little bit in the preparation for this. So you have the book out there, Practical OpenTelemetry, and writing a book on a topic that is so new and is so fast moving. I mean, isn't it? How do you what is covered in the book that won't age? Let's say that
Well,
way.
it's
That
3
won't
pages
be.
long, right? It's 3 pages long, and then he just publishes a new addendum.
Pretty much. It was challenging. I think from the moment that I started writing the book to the moment that I finished, like things moved, and especially in the logs, in the login side, which is the area of OpenTelemetry that is still experimental in some ways, not stable, not fully stable, at least from the point of view of APIs. But yeah, so there are parts of the book that are stable, like the metrics API, the tracing API, the baggage API, all those parts of the OpenTelemetry API are stable. The SDKs that come with them as well are stable, and OpenTelemetry does provide some really strong stability guarantees on these libraries. So if you can take long-term dependencies on it, and in a way, my book is taking long-term dependencies on these APIs, right? I mean, it does in the intro, it does mention at what point it was written and to what point it was compatible with. But yeah, so the stabilization of metrics and traces was probably what made, at that point, it made sense to create a book. Now we've got the login API that is a lot more stable than when I started writing it. But yeah, so I think if you look at the concepts around metrics of the API and the concepts around traces, all those will be stable. How you integrate with OpenTelemetry collectors will be stable as well, and even and the protocols that are used to publish and to export this data is all stable. And then there is a bit in the book that is not really, I mean, it's related to OpenTelemetry, but the start and the beginning of the book is related to observability in general and how you can roll out an observability function within your organization and how to make engineers adopt best practices. So there are bits in it that are not specific to OpenTelemetry as well.
And that's actually, thanks for this perfect segue almost, because this is what I wanted to talk about. I mean, obviously for OpenTelemetry itself, there's a lot of information out there online in the communities. Folks, if you're listening in and you want to learn more about OpenTelemetry and you don't know where to start, we put a lot of links in the description of the podcast, and obviously, start with the book, Practical OpenTelemetry. But as you said, many organizations are currently trying to figure out what does this all mean. How do you just said how to build an observability function? How do you convert from maybe something that you used to do to using open standards now? Where do you start? What are best practices? How do you get started? Like looking at your own history at Skyscanner, can you share some of the thoughts that went into what was a good starting point? What type of people did you need? What type of practices? What did you set some goals to say, hey, in a year we need to be there, or anything could be really helpful?
Yeah, so we had a really complex. I mean, at Skyscanner, we always relied on open source libraries, open source tooling for anything related to telemetry. We were integrated with some vendors in the past, but in general, we try to basically run everything in house. And this basically we started with, when we started to adopt OpenTelemetry, we started with tracing. Now, two reasons for that. The first one being is it was the most stable signal at the time. The second one being that we were already relying on open tracing. So if you're like OpenTelemetry being the merger of open tracing and open sensors, two other projects. So if you're like a user of open sensors or of open tracing, you're going to have a really easy migration path. And this is intended, but as well, it shows the value of the API design of OpenTelemetry. So you've got that separation between the API and the implementation, right? Open tracing already had that same design. And for us to basically adopt open tracing, we could sort of do it pretty much under the hood. So you can just apply a shim, and that says every time you call the open tracing API, that will be translated into the OpenTelemetry API call, right? So there is a lot of, as well in the industry, in the tech industry, you've probably had guests on your podcast as well that talk about platform engineering as a discipline, right? At Skyscanner, we have been invested in platform engineering for a long time. And when we were approached with the decision to adopt OpenTelemetry, we already had things in place, like, for example, a set of internal libraries that we can roll out to across the company. And they contain some standard or default config for libraries, right? So for us to migrate to OpenTelemetry, the tracing part to OpenTelemetry was pretty much a minor version bump of that internal library that said, well, now you configure the Open Tracing API like this. And then people could start to basically gradually move to OpenTelemetry. Now, now that was the easy part, let's say. You've got a new technology, you've got tracing, you've got support for, for OpenTelemetry, and everything is all rainbows and it's all nice. Now, the hardest part, I think, to adopt is when you've got a legacy system or a system that's been running for years, and that their engineers are used to using metrics and logs, and that's it, no tracing. So then how do you go about instrumenting a service like this one? And this is where, there is a lot of education that's needed, a lot of enablement as well, but education on what is the best signal to use for a specific concept, right? Because when you've got something like OpenTelemetry that allows you to use any of these three main signals, like traces, metrics, and logs, how do you know which one to use for something? And this is where, this is what I wanted to take my book into, that sort of aspect of okay, you've got all these things, but if you want to, I don't know, look at requests for a particular service, do you add it as a metric? Do you add it as a trace? What sort of information do you put in each of the signals? And then basically that's the part that we're sort of still going through now as Skyscanner, is adopting metrics and then having to review some of the metrics that were produced by your application, right? Some of them could have been really high cardinality metrics because there was nothing else and they were used to debugging that. Maybe you can stop producing those really high cardinality metrics and then link to traces, which have that sort of really granular view that you're interested in for debugging. And then maybe drop some of the logs and also rely on tracing. So it's that sort of re-instrumentation of services is challenging for teams, but there is a lot of return on investment here on using each signal for its purpose.
So I hope I don't divert now, but I think you just triggered something in my head. Talking about what to choose, metrics and traces. And I give you a practical example. The metric of response time, right? We are interested in response time of transactions. So I think there's two ways we could do this, right? We are capturing a metric, and for every single request that comes in, we then say, hey, this is the response time, and then we have high cardinality, and we can calculate all of the, your min, your max, your averages, your percentiles, and all that stuff. If you don't choose a metric for this, because you say, why do I need a metric? Because I have it on the distributed trace anyway, because if I start a trace at the beginning of the transaction, then the duration of the trace basically gives me the response time as well, right? So that would be, I guess, an argument to say, why capture things twice if you already have it on the trace? Right?
Yes, I think there is a reason for that, though. I think there's as well sort of a view of okay, well, you only need tracing. We've got tracing now, and we only need tracing. And I personally disagree with that a little bit, because when you've got metrics, when you've got a service that is producing thousands of spans per second, but you've got metrics that can aggregate a lower sort of a lower cardinality, you can the pipelines that you use to export these metrics, or the retries that you can have on a specific data point, or even if you use Prometheus, for example, or cumulative counters, the way that the metrics are designed, they're more stable. They will produce a more stable signal than traces or spans. And if you've got then sampling applied on top of spans, which I think we can go into sampling later as a way to only keep the data that you care about, that you can aggregate those metrics, have all the events count, but in one aggregated data point, and then link to individual examples that are in traces that will allow you to debug sort of further, deeper down, and save costs or save transfer payloads and so on. Basically optimize what you're actually storing, what you're actually sending over the wire.
Well, thanks for that answer, because that was, I'm hoping you're going this direction, because that's exactly what we have seen in our experience, right? Because as sampling at some point comes into play, you would basically lose a certain level of visibility and accuracy. And I think this is something though where I believe what you're doing with the book, what you're doing in the community, what we're doing here with the podcast is so important, that we make people aware of this, because I think a lot of people are now entering the observability space and may not have thought about these implications, right? Because on a Hello World app, everything works perfectly. But like if you look at, I guess, in your environment, right, at Skyscanner, you have high transaction volume, and then the question is, do we really need to capture? Can we even capture? Is it cost efficient to capture every span?
Yeah, it's not. I mean, it's not. It's I can give you some like details off the top of my head, and that is like, because you think about Skyscanner, it's, we receive, we have an average of over 100 million monthly active users, right? But then when you think about the internal systems, because it's, is a travel search engine for flights, hotels, car rentals. Every time that someone searches for something, you need to call multiple partners, multiple airlines. So it's like basically like a fan out sort of thing, right? So the amount of traffic that goes on internally in the systems is, could be like hundreds of times higher than you see from like when you normally interact with that. If you've got a service or a system where it's like a normal user interaction with the system itself. Yeah, we here have like, thousands of partners that could be called. So in terms of like, we produce around 1.8 million spans per second that goes through our collectors. Now that's a lot of data, and a lot of data that most of that is probably not that useful for debugging, because it is normally, it would correspond to successful requests or to requests that completed in a acceptable amount of time, right? So like the ones that are not really that useful for debugging, you want to keep those in the metrics. I mean, you want to know about the general state, but then, not that useful for debugging. So at Skyscanner, we use tail-based sampling, which is where like in traces where you can look at the whole trace and then try to, you can just basically make a decision looking at a whole trace instead of like one particular service. And we tend to keep around between 4 and 5% of all the traces. And this is enough. This is enough because it contains all the traces that contain a single error. It contains the slow traces and a random percentage of the rest, right? And if we need to store more, we can store more. But like generally, that's what we keep. And we've seen as well teams that migrated from logging to tracing, like, basically, and get better observability. It's not like they stopped doing logging, but for example, they stopped like debug level transactional like logging, and they started to rely on tracing, and they just didn't get better observability. They reduced their operational costs as well, which is, a benefit on both sides.
I think there's another big aspect with the metric versus the trace there is just the simplicity, right? I mean, metrics, if you're going to get a response time from the traces, you're basically going to turn that into your own metric, which means now you have to add some calculation layer to it. And you're also going to not have every single data point on a chart or something, right? So you're going to do maybe a 1 second, 10 second, 30 second resolution, and the metric's already there. It's already done. So why would you need to reinvent that? Even with the logging thing too, this comes up all the time. There's the idea of logs are still relevant, right? People still use logs plenty. I know back in the old days, Andy and I used to hear like, oh, we don't need logs. And then our developers were like, no, we still need logs. And we've had some podcasts of like when we started adding logs back into our platform, it was like, well, yeah, no, people still need logs, but you need logs for certain things. If you have traces, you can get that information from the trace, which you're already collecting. This way you can save on your log stores by saying, what are the things that we can only get from logs? What are the use cases that are specific to log? And let's keep the logs focused on that. And let's leverage these other things that are going to have a bunch of other rich additional contextual data in it for those other pieces, right? I don't need that in a debug log, right? For instance.
Exactly. There's as well another benefit of logs and how they integrate with OpenTelemetry is that you have legacy systems that their libraries may not be instrumented for OpenTelemetry or for tracing.
Right.
But thanks to these sort of like correlation and semantic conventions as well, you can then instrument your logs so that they appear next to your traces, right? Which as is not a use case per se, but is like something that it may ease the way for a lot of people that say, well, I mean, you still get that information from logs attached to your traces, which I think it's great to basically try to give more context around these anomalies that you can find from tracing data that you couldn't find from logs.
Yeah.
Hey, I gotta jump back to something you said earlier, because remember, maybe not everybody's completely familiar with all the terminology. You said you're capturing about 4 to 5% of your spans, and because they contain enough error. You mentioned tail-based sampling.
Yeah.
Could you just explain what tail-based sampling means again? Remember, there's some people that may have never heard about it.
Yeah, there is generally two forms that you can do sampling, right? The first one is probability sampling. So you've got, and you can think about if you think about logs, for example, the only way that you can do sampling on logs is probability sampling. So you've got, a percentage of logs that you want to keep. In the same way that you can apply that to your traces, you want percentage of traces that you want to keep. Now you may be able to say, well, if there are error, for example, error level logs, you may want to keep 100% of them, but only 20% of the debug logs. But then the problem is that when there is an error, you actually want the debug logs. So that's why people don't end up like sampling debug logs, is because they actually need them. So with tracing, when you think about probabilistic sampling, it does give you a bit more, which is that you can actually say, if you want to store a trace, you can store the whole trace. And that means that spans from every service that a transaction went through, right? So you're going to keep the whole trace. The way that tracing does it is like you can propagate that decision. So when in the same way that you propagate a trace, you can propagate that decision. So if you have a server request, or a server that is accepting a request and says, well, I want to sample 20% of the traces, then when it makes the decision to sample, it can then propagate that decision downstream. And that's powerful by itself, but it's still probabilistic. You're basically saying, I want to keep 20% of the traces, and that's it. With tail-based sampling, it is a bit more difficult to implement because it does require you to have an external component that all your spans for a particular trace go through. So think about, you've got 3 services in a trace. Each of them will be producing their spans. You need to feed all the spans through one single replica of something, of a collector or some other way of multiple vendors will provide their own tail-based sampling as well. But you need to send it to all the spans to one single point, all the spans for a trace. So when one of those samplers, which could be an OpenTelemetry collector, gets the first span for the trace, it starts a counter basically. And then when it starts to keep all the spans in memory for that particular trace. And when the counter comes to the end, they can say, the OpenTelemetry collector or whatever sampler, it can say, okay, I'm looking at the whole spans, at all the spans in this trace. And I can say, well, if there was any error, for example, in this whole trace, I keep the trace. If there's no errors, well, then I look at the duration of the whole trace. If it goes over a particular threshold, then I'll keep it. If not, then I'll discard it. And then you can as well do a bit of probabilistic sampling there. But the idea here is that you can look at the whole trace because at the spans for multiple services at the same time, and then decide if you want to keep them or not.
Cool.
So we think that is very powerful because that is,
it is, yeah.
You end up basically only storing the data that is useful and then discarding the rest.
Yeah.
Would you also keep, I imagine, you'd probably also keep ones that are running nominally so that you can compare bad to the standard, right? So it's going to be a mix of types, not just keeping bad, right? You'd want to keep some of the standards so you understand what it should look like, right?
Yeah, so you want to keep a percentage of the good ones as well, just to understand what good looks like. But
coming back to something that we also discussed in preparation of this, and the people that are building in OpenTelemetry or any type of observability data are in the end going to be the developers, right? The developers that have their own, they want some information from their own code, or developers that are building frameworks that is then used. They're the ones that know their code best and they know what they need. Is there good enough best practices out there to either tell developers what is good to instrument and also what is not good to instrument, or is there any tooling out there that actually looks at traces and says, hey, you know what, this is actually useless information, or it's too much, or it's dangerous information, it might be secure, it's like confidential information? Because I always worry that what we've seen in our world 15 years ago when our product, or also 10 years ago when our product was much different, we had the option to say instrument everything. So we could specify method matchers or rules. You could do what we call the shotgun instrumentation. Shotgun meant everything in a certain package, or maybe somebody could do star.star and then everything got instrumented. And basically that was extremely powerful and great for some in a certain environment, but in production obviously would kill everything because it has a lot of overhead, costs, you name it. Yeah. Are there good enough best practices out there, A, for developers to find, or B, what can developers do to validate if they're doing a good enough job? Is there any validation of the instrumentation?
Yeah, that's a difficult question actually, because I think that is if you look at some of the OpenTelemetry instrumentation libraries, right? You take the OpenTelemetry Java agent. By default, it will auto-instrument every single library that it knows how to auto-instrument, right? Mm-hmm. That could be a lot of information. That could be certainly something that you want to use to test it and to sort of like roll it out if you're perhaps in a small sort of like volume or small traffic. But when you think about rolling it out at an organization level, then you've got a decision to make, which is which ones of these libraries you want to instrument, or which ones of these settings you want to apply. Now there is good news here as well. As like the tooling is there, as in like OpenTelemetry does provide the tooling for you to like enable disable things. Mm-hmm. In general, like what I've seen is not if there is anything that could potentially be sensitive information is normally disabled by default. Like, storing headers, for example, or things like that are not normally stored by default. But then there's a lot of things that you could maybe decide to disable. So the way that we do it at Skyscanner is we've got our internal, basically like an OpenTelemetry distro. That for those that don't know what an OpenTelemetry distro is you will see multiple vendors will have their OpenTelemetry distro. It's not a different implementation of OpenTelemetry. It's just a sort of package configuration that, what components are going to integrate better with that particular vendor. The way that we do it at Skyscanner is we have our own sort of like defaults. And when we roll out OpenTelemetry, we roll it out with the minimal required. And by minimal required, we mean we want the HTTP clients to be instrumented. Mm-hmm. We want the servers to be instrumented. We want some internal, like middleware, for example, internal libraries to be instrumented. But in general, we don't instrument all. And then, because there is a lot of things that we want to roll out by default, and then allow service owners to add their own, to be able to configure their own. And the way to look at it, I guess, is how basically is what's useful to you to debug your service. That's going to be very much dependent on each service owner. There's also good news on the metric side. I was talking mostly about traces here, but on the metric side, one of my favorite things actually of OpenTelemetry metrics is the concept of metric views, which allow you to, let's say that you're a library author and you say, I want to instrument this client, this HTTP client, and I want to put every single, URL in it, which is not a semantic convention anymore. But let's say that, someone says, I want to put every single URL in a metric as a tag. Now that could be a really high cardinality tag if you've got the URL in it. Now with metric views, what you can do is you can just go in, remove that, and basically re-aggregate the metric at the service level without having to change how the metric is instrumented. So that leaves the developer of the library with the option to say, these are all the things that you should care about. But then you as a service owner, you can just say, well, actually, I want you to re-aggregate that into less dimensions and then push those data points out. So this is the work that, if you've got a big organization, it's probably good to invest in some So like I like to call it telemetry enablement.
Enablement,
But it's basically, you need a set of people that know what they're doing and that know how things are instrumented and then can provide these defaults and say like, this is a default metric view for this particular library, right? And then that's something that you can roll out internally across multiple teams. Because not everyone has the time to go and look at this.
Yeah.
And then I'm of the approach that is good to have that minimal instrumentation, minimal telemetry, and then allow sort of like service owners to enable what they need then later.
Do you see any testing that is necessary for for the telemetry data? Meaning, are there, like we do functional testing and unit testing, do we need to do telemetry testing so that we actually make sure we get the right telemetry before we push it into production? Have you seen this?
Yeah, I've seen, even when I think this especially when you've got a good practice is to extrapolate, right? So you can instrument your service with a particular library, you run it in your test environments, see what telemetry they produce. You run it then if you've got a pre-prod environment or like a canary deployment, something like that, you can run it there and then say, well, if this is producing this amount of telemetry, is that useful for me to debug? Is it useful data? And then try to basically get the value of like, how much is this going to cost me? As compared to like, is it really useful data that is producing?
It's kind of like observing the observer, really making sure that
there is as well things that you can do when people are instrumenting their services and adding spans or manual instrumentation. I think probably more related to spans is the ability to test that in your unit tests as well. Something that we do at Skyscanner. You can have an in-memory exporter. So then you can use that in testing and say, what spans were generated during this unit test? Is that what you're expecting? Or is context being propagated correctly? And that you can start to look at it that way as well.
Yeah, especially because telemetry data is now also woven into and used by not only, let's say, the developers for troubleshooting or for ops teams, but also by your DevOps tool itself. We mentioned canary deployments, right? We have automated canary analysis tools where your CADA, your HBA, your auto scaling, right? They rely on accurate telemetry data, and if your telemetry data is not good, then these tools may make wrong decisions. Yeah, I think that's a big point. So kind of the quality of observability, kind of even like how can you need to validate that the quality is right and that you have the right data in the right quality. The metrics view was an interesting concept, and I would like to ask one more question, because you said you can define a view and then the aggregation happens. Does the aggregation happen in the app itself then? That means it's on the client side where it's collected, or does it happen in the collector? Where does it happen?
It would happen on the client side, so on the individual server's replica where that is being generated. So it's basically the way that the API works is quite interesting. For me, that was a new concept as well, which is the separation between measurements and their aggregation. Because when you think about, I don't know, the usual like Prometheus clients, you basically get a counter, you add it, and then just get aggregated there in memory, and then you export it. Well, it gets scraped in the case of Prometheus. With the New Relic API, what you're doing is like you're adding a measurement, but the way that these measurements are aggregated is configured as startup, an application startup. So that's what the view does really. It just informs the SDK, the OpenTelemetry SDK, to say, well, this is how you will aggregate these measurements. And you could even change. You could even change the type. You can basically, if you've got a histogram, like whatever library author said, I'm going to instrument this as a histogram, but you may not need a histogram, and you just need a counter. So you can even change the aggregation type, right? So you can say, I just need a counter for this, and then. Normally, as that's a bit of a niche use case, probably not that common, but it could changing the type of aggregation is quite powerful.
Got 2, 3 more quick questions for you. And also coming back to what you said in the beginning, or we also discussed this in our prep call. From an adoption perspective, I see, especially in enterprises that have had software for a long, long time and still running, right? A lot of, let's say, they're quote unquote legacy, for the lack of a better term, software that may never, right? That either they don't have the source code, they didn't write it, but they just run it, and there's no way for them to ask their supplier to put in OpenTelemetry, because what is the benefit for them, or is it worth the cost, right? Or maybe also I think I brought up this use case that I ran into with a client where they said, hey, our software is using this library, but we cannot use the latest version because we're running on an older version of another library, and therefore we have a certain dependency, so we cannot upgrade to something that is instrumented with OpenTelemetry already. So we have a gap. And so this is also why then we still, need auto instrumentation. And fortunately, there are some auto instrumentation agents available now in OpenTelemetry as well, which may fill this gap. But what do you think needs to happen in order to completely fill this gap? Or what can we do to encourage people to also maybe touch some old code and actually instrument those libraries? Because we want to make sure that enterprises that have these legacy systems running around, that they can also benefit from OpenTelemetry, from distributed tracing end to end.
Yeah, so I think, the first thing is communicating value, right? Which is every single one of these discussions should start with like, what is the value in doing this? And then now that's why, there's so much good content out, out there basically to say, this is the value of open standards. This is the value of correlation of signals, of using open telemetry semantic conventions and so on. So I guess, if you've got an old framework that needs to be instrumented, we'll try to basically start those discussions with different vendors or different library maintainers to make them instrumented with open telemetry. Now, there are things, it's not always possible, but in some cases there are ways that you can still use open telemetry semantic conventions with, for example, things like logs, right? We just said you can start to use some semantic conventions around the logs that you produce so they can get added to or correlated to traces, right? And there is also the open telemetry collectors, which allow you to receive some of that data that may be produced in some of the older sort of like ways of exporting metrics, for example, right? StatsD or not old, like some other ways like Prometheus, right? Or there are other basically clients. Some of that, there's like 80 different receivers, like open telemetry collector receivers, which can either scrape or receive data in a format. And then you can do a lot of processing within these collectors to put that, to add those semantic conventions, those attributes that will allow you to then not just, produce it in a standard format, but also be able to put it in context with other open telemetry data.
From an operational perspective, what is more challenging? What do you see? Is it to get open telemetry into the client app to actually generate the traces, or to operate and run all of the collectors and the infrastructure that stores the data?
I was going to go to a third thing, which is was the hardest thing. But in terms of I think the open telemetry collectors are easy to run. They're just super efficient. We run them, as I said, we run a set of collectors as a gateway that accept those 1.8 million spans per second, and metrics are now ramping up as well. And they run with those, I don't know, in total across all of our clusters, I think it's less than 125 cores. So it's quite small CPU utilization for the amount of data that they chunk
process,
through. And even generating metrics and spans, they're not just basically passing data through, they're actually doing things with the data. But I was going to say the most difficult part perhaps is the human part of things. As usual, technology is easy, it's humans that are hard, right? Is how to change those those practices of debugging. Right? We've got, for example, a Skyscanner. We made it super easy for people to go and use tracing data. Like most teams use it, but there will be, we've got a lot of different teams, and there will be some teams that even though they've got the tracing data, they've got a run book that says you go to this dashboard and you go to logs, and they're not used to it because that's the way that they've been operating their service for years. So is that sort of like changing those patterns of using observability data is probably the most challenging part, I think.
Yeah. Definitely see that one all the time where we're engaging with customers and they get these traces, but yet they say, well, we really haven't looked at it much because every time there's an issue, we just jump back to logs, what we know what to do. And there's that idea, okay, well, if you practice the new style for a little bit, there might be a bit of a pain. It's that transition. It's the culture that's got to change in the transition, and try this. And then once you get to that and you get comfortable with that, you're going to find it so much more efficient. But how do you get somebody, especially in the heat of the moment when something's blowing up? Like, I know I can go here. It might take me 3 times as long, but I know what I'm doing, as opposed to trying this new thing. And that's extremely challenging. So I think the practice there is finding a time for people to play or to experiment and poke around when there's not a fire, right? It's to find dedicated time to look into those situations. But,
I actually have a quote. I think there's a quote in my book about that. It says like, the firefighter doesn't wait until the house is on fire to learn how to use a fire engine, right? So then there is some training needed as well. And I think, we've started to do that. So like try to apply that concept, a Skyscanner as well, having some sort of like game days, or just basically teams looking at their telemetry. Something that I'm really keen on starting to do is having multiple teams looking at their telemetry together, because then that has, I've seen that happening, not with the whole team, but with one engineer from one particular area and another engineer from other area. Now they're both part of the same transaction, but the services are part of the same transaction, but they're different teams. And then when they start to talk about telemetry, they're all like, oh, actually, I didn't know my endpoint was being called by your service, or that this endpoint was being called by your service, and that was part of this particular, user journey. And it's really interesting, the conversations that can come out of that.
And I think out of that actually comes another cool thing. If you start to learn about your quote unquote users or customers from your API, and you see when something breaks, why it breaks, you can also start thinking about kind of system boundaries, and then define good SLAs and SLOs, and actually start measuring the right things, and then get right alerting in and all that, right? I mean, that's a big topic. Daniel, I know we are getting close to the end of the hour here, but if you look ahead a year from now, and let's assume you will write a second edition of your book, not because you need to keep it up to date, but you're writing new stuff. What do you think would be in your book? What are the things that are still struggling in your current role or in your current situation? What are the things that you have not solved yet that you need to solve this year, that you want to write about how you solved it?
I think it will probably be, and this is an area where open telemetry is putting a lot of effort now, is in the client side part of things, the front end, browser, mobile instrumentation. And then how do we get that, basically, how do we get what we have in the back end in terms of like correlation, like context and all that to mobile and to browser in a way that is, integrated with open standards and so on. So how do we basically move that context as well to the back end? So propagate all that context and start to basically get an idea of what our users are really experiencing. So, we've got something, for example, we've got Call Web Vitals as something that, we all care about because Google says so. And it is a really, genuine, good way of asserting user experience, right? Those 3 metrics. But there's so much more that could be done to basically assert like what users really care about, and then correlate that to back-end performance as well. So I think that's an area where I'm really looking forward to, next year, next couple of years, it was coming. And then, get the whole view of contextualized data from the customer, from the user to the database, right?
Mm-hmm. Sounds like describing a product that we work with on a daily basis. No, but that's the standard, right? I mean, that's the nice thing.
The standards of it, I think,
Yeah.
And also, when we can get, this is another area where it is related to this as well. You mentioned that SLOs, try to get SLOs for basically that product driven, right? You've got your SLOs that are, that product people, product owners, product managers care about. And then, where you start basically looking at product health in a way that is, driven by SLOs, and then get that sort of like view of like, there is an SLO that's about to break, and then you get into the metrics, and then vendors like, start to basically give that. When we were talking about workflows or run books, basically get those without having to write a run book. Because I think writing detailed run books is a losing game. You're never going to write the perfect run book. But if you can have a data that is there correlated, that a vendor can use to drive you through the SLO to metrics to traces to logs and all that in context, there's still a lot of work to do there, I think.
Daniel, did we miss anything? Did we miss any topic that you wanted to make sure our listeners are aware of as they embark on their journey towards adopting OpenTelemetry? Besides obviously looking at your book, because that's where all the wisdom is.
Yeah, I don't think so. I think perhaps the cost distribution, but I think we talked about that.
Yeah. Are you going? I know you presented at SRECon and at QCon.
I didn't actually. I don't know if I didn't present at SRECon. I presented at recently at QCon. I presented at OliFest before.
Oh, OliFest. Sorry, that was my mistake. Yeah. Any other conference presentations coming up this year?
Not yet. I've been invited to a couple, but I also have a lot of work to do at Skyscanner to adopt open standards.
Yeah. Awesome. Brian, any final words from you? Any new dream that came up in your mind?
Well, but the only dream I have is still one I thought I saw in your notes and we didn't really tackle is I remember when OpenTelemetry was first coming out, there was this promise of all these vendors were going to be baking OpenTelemetry code into their runtimes and everything. And if it's happening, I haven't seen it yet, but I haven't seen everything, obviously, but not seen it in the common stuff yet, and hoping that still comes because I think that'll just make it so much easier for everyone, and it'll be based on the vendor's best practices for what's going to be most useful. The other thing, I like what you said, Daniel, earlier. I remember reading an article about this way back as you kept on talking about collecting all this data, and it could be, overload from a data point of view. And I think, one of the most important components of observability is turning the data into information, which, there's some great articles out there. I can't remember the one I read way back, but it was just, going through the difference between data, which is just data points, right, and information, which is turning it into something useful. And OpenTelemetry obviously is going to help you capture all of the data, and it's going to be up to you to turn that into useful information and find ways that you can leverage that within your organization to make those improvements. So that's the other key component to it.
My hope is that we can get vendors, like the effort that vendors used to basically get on running their own instrumentation agents and their own APIs and SDKs. When vendors move towards open standards for instrumentation and the API and SDK, hopefully all that extra engineering time is put onto using that data, that standardized data, and making it valuable.
Awesome. That's all I had, though, Andy. Hopefully, I'll have another dream for the next episode.
Which I believe is actually also another session on OpenTelemetry. because it's going to be practical implementation tips from one of our users out there on how they implemented OpenTelemetry. So OpenTelemetry is a hot topic, and we are trying to do whatever we can to educate the world. A final statement I want to make, and we discussed this also in the prep call. I think we as vendors that have been in the space for so long, we're really looking forward to OpenTelemetry, because I think it helps us to really focus our engineering efforts on where we can really make a difference, because the data collection problem is something that will be solved with OpenTelemetry, like how and what data, so we can really figure out and solve the problem that Brian, you just mentioned. How can we then convert this data into answers and really focus and then also differentiate there, right? And how and that's going to be interesting. And yeah, I think it's still a way to go, right? Because even though OpenTelemetry is kind of looks like skyrocket adoption, it will still take a while until we have it in a state where we can just purely rely on OpenTelemetry. But yeah, it's going to be good.
Yep.
Good future.
All right, well, awesome. Well, then, Daniel, thank you so much for joining us today. I was a bit quiet today, but it was, I think, a lot for me to learn on today's episode for sure. Plus, I was still stuck. I couldn't stop thinking about you dancing around on the moon, doing the salsa, dancing on the moon. But to any of our listeners, if you have any questions, comments, topics, feel free to, send us an email at pure_DT. And love to hear from you. And thank you, everybody.